All right, let's talk about robots. If we want them to get smarter, more capable, they need better fuel. And I'm not talking about fuel for their motors, but for their brains. Today, we're going to dive into a brand new source of that fuel, a huge new data set that could totally change how robots learn to interact with the world around them. So, let's get right into it.
So, let's just kick things off with a pretty big question. What do you think is the single biggest thing holding modern robotics back, right now? Is it faster processors? Nah. Maybe stronger motors? Or is it all about writing, more clever algorithms? Well, it turns out the real bottleneck is something way more fundamental.
Yeah, believe it or not, the biggest roadblock isn't the code, it's the data. Or more specifically, what researchers are calling the extreme scarcity of high-quality data. I mean, think about it. It doesn't matter how brilliant your AI algorithms are. If you can't feed them the right information, they're basically just fumbling around in the dark.
And this whole data problem? It's a massive deal for something called embodied AI. Now, what's that? Well, to put it simply, it's AI with a body. A robot. These aren't systems just crunching numbers in the cloud. They have to physically interact with our, let's be honest, messy and totally unpredictable world. And to get good at that, they need data that perfectly captures all the physics and all the little details of how things actually work.
So, what's the fix for a data scarcity problem? Well, you create a new, much better source of data. And that, right there, brings us to the star of our show today, a project called RoboManip TrajDemo. It's designed to do exactly that.
Okay, so this data set comes from a company called CoData. And here's the really important part. They've made it completely open source. That is a huge deal. It means any researcher anywhere in the world can get their hands on it. And this isn't just, a bunch of random videos thrown together. Nope. It's been meticulously built from the ground up for the super demanding fields of embodied AI and computer vision. I mean, this really shows you the kind of leap we're talking about here. The old way, you were stuck working with data that was super limited, maybe kind of blurry or low res and just plain hard to get. But with this new data set, it's a total upgrade. We're going from scarce to accessible, from fuzzy to ultra-high precision, and from just basic info to data that's packed with rich, meaningful annotations.
Okay, so I keep throwing around these terms like high precision and richly annotated. But what does that actually mean when the rubber meets the road? Let's pop the hood and take a look at what makes this data so special.
Right. This is where it gets really cool. See, this data set doesn't just show a robot what happened, it shows it exactly how it happened. We're talking precise 3D coordinates, so the AI knows exactly where every single thing is in space. It's got annotations for key events, so the robot learns the difference between, say, reaching for a cup versus grasping a cup. And it even tracks the robot's own body posture and the exact path of its movements with insane detail. It's kind of like the difference between watching a grainy the home video and having the full architectural blueprint for every single action.
Okay, so we've got this incredibly detailed, super rich data. That's great. But so what? What's the end game here? How do we actually turn all this information into a robot that's smarter and more capable in the real world? Let's connect those dots, from all this data to actual action.
So, with this kind of high-precision data in hand, what can engineers and researchers actually do? What new skills, what new abilities are suddenly possible for our robots?
Well, this data helps tackle some of the absolute hardest problems in robotics, things like trajectory prediction. In plain English, that's teaching a robot to guess where a moving object is going to be a split second from now. Or how about fine-grained control? That's all about giving a robot the delicate touch it needs to do something like, thread a needle. It even lets us analyze the super subtle physics of exactly how a robot's hand makes contact with an object.
You can kind of boil it all down to a three-step process for building a smarter robot. Step 1, the data teaches the robot to predict. It learns to see the start of an action and make a really good guess about how it's going to end. Step 2, it uses that new skill to fine-tune its own movements, making them unbelievably precise. And finally, step 3, it learns to analyze what it just did, gaining this deep, real-world understanding of physics and touch.
And maybe the best part of this whole thing, this incredible resource isn't locked away in some top-secret corporate lab. Nope. It's basically an open invitation to developers, to researchers, even to hobbyists, anyone, anywhere, to come join the frontier and start building the future.
So, when you boil it all down, the story is actually pretty simple. The whole field of robotics was facing a huge problem. A lack of good, detailed data was holding everything back. And this project? It's the solution. It's a rich, precise, and totally open data set designed to tackle that exact problem head-on.
So if you're listening to this and thinking, I want to try this out, well, you can. The entire dataset is up on Hugging Face right now, ready for you to explore and download. And hey, if you want to be part of building the next generation of AI training data, you can even contribute directly on Codada's website. This is truly a community effort, which is awesome.
Which, of course, leaves us with one last really exciting question to think about. With data this detailed, this powerful, what's the very first problem you would teach a robot to solve? The tools are officially out there. The only limit now is our imagination.